In today's lesson, we're going to be factoring quadratic trinomials when the leading coefficient is 1. You might recall from previous lessons that factoring will reverse the distributive property. So to begin, we're going to multiply two linear binomials together using the distributive property and take a look at the resulting quadratic trinomial to see if we can identify any patterns that would be helpful for factoring. Let's use the table to format our work. We're ready to begin using the distributive property. We're going to multiply x times x, and that yields x squared. We're going to multiply x times 5, that yields the product 5x. Moving to the second factor, 2 times x yields the product 2x. And multiplying 2 times 5 yields the product of 10. Now let's combine like terms and write the result. X plus 2 times x plus 5 equals x squared. We're going to combine like terms, 5x plus 2, so that's 7. X's go along for the ride. And then write the constant, which is the product of 2 and the 5, on the back end. So let's examine the quadratic trinomial that resulted. Notice that we got the 7 by adding the 5 and the 2 together. So I'm going to write that down quickly. 2 plus 5. Now notice that those two values that we just used are in these positions, the second terms of the two linear binomials. So we're going to refer to those two positions as P and Q. So we can say that the middle term of our quadratic trinomial is actually the sum of P and Q, in this case 2 and 5, which is 7. Also, the 10 was the result of multiplying the 2 times the 5. Notice once again that those two values are found in the P and Q's position. Now we can use this pattern when we reverse the distributive property and go back to the two linear binomials that gave us the quadratic trinomial. Let's take a look at another example. We're going to multiply x plus 5 times x minus 6. Once again, we're going to use the distributive property. We're going to organize our work using a table. Writing x plus 5 across the top. And the second factor, x minus 6, along the left side. And now we are ready to distribute. X times x yields x squared. 5 times x yields the product 5x. Moving to the second term, we're going to multiply the x times the negative 6, and that yields opposite 6, x. And then multiplying the 5 times the negative 6 yields opposite 30. Now let's write the result. X plus 5 times x minus 6 yields the quadratic trinomial x squared. We're going to combine like terms. 5x plus negative 6x yields a negative 1x. And then we're going to attach the product negative 30 on the back end. So the two linear binomials, x plus 5 times x minus 6, yielded the quadratic trinomial x squared minus 1x minus 30. Now let's take a look at how we got the result from the two linear binomials. Notice once again that to get the negative 1, we added a 5 and a negative 6. Now notice that those two values are once again in the positions of the second terms of each of the two factors. Also, the negative 30 was the result of multiplying the 5 times the negative 6. So the product, negative 30, can be thought of as just the product of the second two terms in our linear binomials, otherwise known as P times Q. Now remember, when we factor, we're going to be reversing the distributive property and moving from this quadratic trinomial back to the two factors that yielded that quadratic trinomial. So we're going to be reversing the distributive property when we factor. Let's factor a quadratic trinomial whose leading coefficient is 1. Now we will recall from our previous examples that when you factor a quadratic trinomial whose leading coefficient is 1, we get two linear binomial factors. We can use this knowledge and the patterns that we developed in the last two examples to factor it quickly. And we know from our examples that the factors of 15, we're going to call those P and Q, have to sum to the middle term, which in this case is 8x. This will help us find those two factors quickly. Let's make an organized list. In the right column, we're going to write down the factors of 15, and we're going to call those two factors P and Q. In the left column, we're going to write down the sum of those two factors. And when that sum yields 8, we know we have the two factors that we're looking for. So let's begin. Factors of 15. Well, 1 times 15 is 15. However, when I add 1 to 15, I get 16. And 16 is not 8. So I know that the two factors are not 1 and 15. So let's try a second guess. How about 3 and 5? So 3 times 5 is 15. And when I sum those two factors, I get a sum of 8. And this is what we're looking for. That tells me that P is going to be 3 and Q is going to be a 5. So now we're ready to write down the two linear binomial factors that gave us the quadratic trinomial. So we open up two sets of parentheses. We write down the factors of x squared. There are two, x and x. Now we look at the value of P. In this case, it's a positive 3. We're going to write that into the P's position. The value of Q is a positive 5. We're going to write that in the Q's position. So the factors of x squared plus 8x plus 15 are x plus 3 times x plus 5. Now let's run a quick check to make sure that we factored it correctly. We're going to use FOIL to do this. X times x is x squared. X times 5 is 5x. Multiplying the inner terms, 3 times x yields a positive 3x. And multiplying 3 times 5 yields a positive 15. And we're going to combine like terms. We get x squared plus 8x plus 15, which is the same as the expression that we started with. So we know that we have factored x squared plus 8x plus 15 correctly. In example 2, we're going to factor the expression x squared plus 6x minus 16. Now we know from our previous examples that when you factor a quadratic trinomial whose leading coefficient is 1, it's going to yield two linear binomials. So let's take a look at the pattern. We know that the factors of P and Q have to multiply out to a negative 16. And those two factors have to sum, in this case, to a positive 6. So let's set up an organized list to keep track of our guesses. In the right column, we're going to keep track of the factors of negative 16, called P and Q. In the left column, we're going to keep track of their sums, so we know when we can stop guessing. We want to use educated guesses as we work through this. So let's begin with the first factor. Perhaps it could be a negative 1. So negative 1 times a positive 16 would yield a negative 16, but when I add those two, I get a positive 15. And that's not 6. So we need to look at different factors. Well, let's try 4 times opposite 4. Well, 4 times opposite 4 does yield a negative 16. When I add those two factors, it yields a 0. So let's attempt a negative 2 times a positive 8. Now, negative 2 times a positive 8 yields a negative 16. And when I add those two factors, I get a positive 6, which is the middle term. So now we know that we have found the two factors that we're looking for. So we can begin to write down the factorization. X squared plus 6x minus 16 is going to yield two linear binomials. The first term of each binomial will be the factors of x squared. Those two factors are x and x. The second terms will be the factors that we just found. The first value of p is a negative 2, so we're going to write down minus 2. The value of q we found to be a positive 8, so we'll write that into q's position. So we think the factorization for x squared plus 6x minus 16 is x minus 2 times x plus 8. To check this, we're going to run the distributive property. I'll organize my work using the FOIL method again. X times x yields x squared. X times a positive 8 yields a positive 8x. Multiplying the inner terms, completing the distribution process, yields a negative 2x. Multiplying the negative 2 times a positive 8 yields an opposite 16. We're going to draw the line and combine the like terms. X squared, combine the like terms, 8x minus 2x yields a negative 6. X comes along for the ride with the constant of negative 16 on the back end. So we can see that x squared minus 6x minus 16 is the same as the initial quadratic trinomial that we started, so we have factored correctly, and the two factors are x minus 2 times x plus 8. Let's factor a third example, x squared plus 8x plus 12. Now the factors of 12, once again, are going to be called p and q. And when we find the two factors of 12 that add up to a positive 8, we're going to know that we have the two factors we need. So let's begin. What are the factors of 12? Well, let's start off with 3 times 4. And notice the product is positive and the sum is positive, so we know that both of these two factors need to be positive. Well, 3 plus 4 is 7, not 8. We're very close. So let's adjust our guesses at the factors. Two positive factors of 12 would be 2 and 6. 2 times 6 is 12. When I add those two positive factors, I get a positive 8. So we found the two factors that we're looking for. Now from our previous examples, we already know that the two factors are going to be linear binomials. And because the leading coefficient is 1, the first term of each binomial will be the factors of x squared, in this case x and x. So now it's just a matter of plugging in the p value that we found and the q value. The p value is a positive 2, and the q value is a positive 6. Now I would like you to run the check on your notes. Make sure you bring your notes to class tomorrow so we can see if you ran the check correctly.